Good day, everyone. So we're going to go over section 2.2, and the first thing that we're going to talk about are variables. So you've heard of variables before. So here, a variable is a characteristic that can differ from one person or thing to the next. And so, you're used to variables in, say, algebra. You have things like 2x plus 5 is equal to 10, and then you would solve for x, and you would say, that x is a variable. Well, variables are handled differently in statistics and actually in most applications outside of pure math. Okay, and so a variable uh, is handled differently in statistics. Okay, so what exactly are variables in statistics? Well, you could have a variable that looks like this. And so remember, we talked about this back in 2.1, being an either undergraduate or graduate, so some sort of rank. And so notice here that we have data here that is actually, the raw data is not numbers. Okay, and so variables can produce data that are non-numerical, and we'll talk about that here in a little bit. We also had ages, remember that? So we had, that could be a variable, because here, notice it varies from person to person or thing to thing. Okay, and so we have age. Okay, and so that's what we're going to talk about in 2.2 are variables. Okay, we're going to break it down further than this. Okay, so we have types of variables. Okay, so what are the different types of variables? Well, we have categorical variables. Okay, now in statistics and a lot of times in math that we have different wording for this exact same thing. And so if we run across that, I'll give you both words. Okay, so in this instance, categorical variables is also known as qualitative. So if you hear qualitative, and many people do in another class, we're talking about categorical, but this book uses categorical, so that's what I'm going to use. Okay, so categorical and qualitative are interchangeable. So a categorical variable, the data is a group or category, so it's usually not a number. It could be. We're going to kind of go over that here in a little bit when it could be. Okay, but let's keep it broad at this point. Okay, so when we talked about undergraduate, graduate, okay, that would be a categorical variable. Or you could even ask a person, "Are you an undergraduate student?" And they would either answer yes or no. Still be categorical, right? Or you could ask, what are you a freshman, sophomore, junior, senior? What's their rank there? Okay, all categorical things. All right. So here are some examples of categorical, like person's favorite color, type of car a person drives. Are you married? Okay, so if you ever have a question, if is something categorical, just answer it yourself. How would you answer these things? Favorite color, you wouldn't answer with a number. Type of car you drive, you wouldn't answer with a number. Are you married? Yes or no? Okay, and so just kind of answer the question yourself, and how you're answering it will tell you if it's categorical or not. Okay, usually, anyways. Okay, what else? What other variables could we run into? In contrast to categorical, we have quantitative variables. Okay, the data is numerical that has a scale. Okay, that has a scale. So let's go back to age here for a second. Obviously, the data is numerical here. Okay, and so what do I mean by scale? Let's talk about that. Well, let's see. I have here the first person is 18, the second person is 19. So we could say then, since this is on a scale, we can say that the second person is 1 year older than the first person. Okay, or you can do any kind of math, division, subtraction, multiplication, whatever. Okay, addition. Okay, and it makes sense. It has a scale to it. All right, and not all data that looks numerical has a scale. I'll give you an example. Social Security number. Okay, so let's say a person had a Social Security number. Now nobody has a Social Security number of this of 000000001. Okay, and then somebody has a Social Security number of 000000002. Does that mean somehow the second person is twice as twice as much as the first for some reason? No, there's no scale to it. Okay, so once it doesn't have a scale to it, maybe it's not quantitative anymore. Okay, it has to have a scale to it. So Social Security number, even though it's a number, okay, it's not really quantitative. It's actually categorical. Okay, so if the number doesn't have a scale to it, these different numbers, okay, it's probably categorical. Okay, um, so keep that in mind. All right. Oh, here are different quantitative variables. So like cost of textbooks that you might run into a semester, number of TVs that people or families own, ambient temperature, right? Salary. These are all quantitative variables. Okay, you would answer all those with a number. If somebody asked you, how much did you spend on text this semester, number of TVs that your family or you own, ambient temperature outside right now, that where you're at, salary. Okay, all things that we would answer with a number. Okay, that has a scale. Okay, so let's go back to categorical. Okay, categorical can actually be classified even further. So there's your general categorical variables. Okay, but there's also a specific type of categorical variable, and that's ordinal data. Ordinal. Okay, ordinal meaning order to them. Okay, so ordinal data looks quantitative, but it isn't. But it can be ordered. Okay, it can be ordered. And so I'll give you an example. Okay, to me this would be ordinal, where there's some sort of order to it, but there's no scale to it. So you know how like we call January month 1, we call February month 2, March month 3. So there is an order to it. Okay. So notice, when you fill out a form, a lot of times they don't put January. Give me a number, okay, for that month. Okay. And so there's an order to it. All right. But there's no scale. So, for instance, April 4, the month, it's month 4, isn't 4 times as big as, say, January in some way, shape, or form. Okay? It's just that there's an order to that. Okay? And so, got to pay attention to, if these things are ordinal or not. Okay? And I want to bring up something because you guys are going to be doing a project and later on in Intro 2. Okay? And sometimes teams get into some issues. Okay, let me show you. So I want you to pay attention to this one. Okay, so let's say income. All right, let's say that you ask someone their income. Well, if you enter the data as 75,000, 120,000, okay, 46,000, that would be a quantitative variable. However, if you go ahead and decide to enter the data as groups, so for instance, maybe you decide group 1 or group A in this situation is less than $50,000, and group B is 50,000 to just less than 100, and group C is greater than or equal to 100,000. Well, guess what? You've just changed a quantitative variable into a categorical variable. Now it has groups to it. Group A, Group B, Group C. There's no more numbers to it. Or even if you said Group 1, Group 2, Group 3, it doesn't matter that you gave it a number. Okay? There's still no scale to it. Okay? Because for the individual people, they're somewhere located in, the less than $50,000 range. Okay? And Group B or Group 2, okay, the second person might be in there. You don't know how much bigger group the second person is from the first person if you just put, group 1, group 2, group 3, or group A, group B, group C. Okay? And so once you do that, you've changed this into a categorical variable that is actually what? Ordinal. Okay? Because there's some order to this. Okay? Group B is higher than group A, group C is greater than group B. Okay? But that's all you know. All right? So you got to pay attention to that. How are you going to enter that data into the computer will determine if you have a quantitative variable or if you have a categorical variable, okay, or for that matter, ordinal, okay. So ordinal is a categorical variable, all right. So be careful on how you enter the data into the computer, okay. And so I'm just telling you because I've run into this problem in the past. Okay, and so let's just kind of make sure that everybody understands it now. Okay, all right, let's continue. Quantitative variables, okay, are broken down into pieces parts. So you have discrete variables. Okay, so a discrete variable is quantitative, and so is continuous. Okay, so let's talk about these guys. All right, so we have our discrete, we have our continuous. Let's contrast these two. So discrete can take on a specific value that can be listed. Okay, so generally the data take on whole numbers such as 0, 1, 2, 3. Now, I'm not saying that it has to be a whole a number such as 0, 1, 2, 3. It could be negative. Okay. Now, normally we don't run into negative data, but we could. Okay. I'll give you an example. Profit. Profit could be negative. Okay. And and so there's been times that I've given a problem in class or even on a test where it would be the profit for like a one of those scratch off lottery tickets. Okay, and that turns into a nice whole number, but the profit could be, like if you spent $2 on the ticket and you didn't win anything, well, your profit's minus $2. Okay, so takes on an integer. Okay, and so we could throw that in the discrete world. Okay, but generally speaking, when we talk about discrete stuff, we're talking about things that take on the values of 0, 1, 2, 3, 4, 5, so on and so forth. Okay, so examples of this would be like number of questions on an exam, number of televisions owned, number of songs on a device. Notice in English how we kind of distinguish between discrete and continuous. Discrete, generally we say number of. We're asking for a very specific number of something. Once we do that, okay, it's usually going to be a discrete variable at that point. Okay, and notice these are all variables that can take on a number, so it's quantitative. Okay, number of songs, number of televisions owned, number of songs on a device. Okay, what about continuous? Continuous. Every value in an interval is possible at this point. Okay, and so what's happening here is that it brings in all the variables that can take on decimals. Okay, take on decimals now. All right, and so what do I mean by every value? Well, we're not limited to things like 0, 1, 2, 3. It can take on the value of 2.12 or 2.1246 or 2.124693444444. Whatever. Okay. Just depends on how we want to enter the data into the computer, how many decimal places we're going to stop. Okay. So things like height, weight, temperature, volume, time, speed. These would all be continuous variables. Okay. And so they can take on decimals. Okay. It just depends on how closely we want to make put this data into the computer. How precise do we want to be? Okay. Now I just want to bring up, I didn't necessarily put this on the slide. You might want to add this, is that generally speaking, continuous variables tend to be related somehow. Okay, think about this for a second. Height, weight, temperature, volume, time, speed. Do we count those things? No. You know why we don't count those things? Because we count in whole numbers. 0, 1, 2, 3. Okay? Continuous stuff, we don't count. We don't count height. We don't count weight. We don't count temperature, volume, time, speed. What do we do with all those? We measure those things with an instrument. Okay? We measure those things. Get very precise with it. Okay? And so notice all those things. We have a height, we have some sort of ruler, right? Weight, we have a scale. Temperature, we have a thermometer, so on and so forth. Okay? Clocks and speedometers, so on and so forth. Okay? These are all measurements. Okay, so if it's a measurement and you can add another decimal to the end of it and it still makes sense, okay, meaning the number makes sense to you. Like for instance, number of songs. If I told you that I had 54.3694 songs on my listening device, you would go, huh? Right? Because you're expecting what? A nice whole number, right? Whereas if I said, well, weight, okay, something weighs 12 pounds. Okay, that's fine. But it could also weigh 12.1 pounds. Does that still make sense to us? Yes. Could we say 12.13 pounds? Yes. Could we say 12.138 pounds? Yes. So as long as we can add another decimal to it, okay, and it's probably going to be measured, okay, it's continuous. It can take on any one of those values. All right. Now, I don't want you to be confused about something. Believe it or not, age falls into the continuous world. And you go, that sounds a little strange. Well, age actually is actually continuous. What is age? Age is actually it's just time. Okay, and we usually put it in terms of years. Now, if I ask somebody what their age was, probably somebody's going to say, "Well, I'm 21, or I'm 26, or I'm 48." They're going to give it to me in whole numbers. Okay, but does that mean really that that automatically makes it discrete? No. And believe it or not, we can actually learn something from kids on this one. Okay, believe it or not. So maybe you have kids of your own, or maybe you have nieces and nephews. Okay, if you don't, well, here you go. So if you go up to a kid, and let's say they're like, somewhere between the ages of 2 and 3, you go, "How old are you?" And they'll go, "I'm 2.5." We can actually learn something from that. Okay, what they're telling you is that they live basically 2 years and 6 months. Okay, and so really, age is just time. Okay, and we could actually go ahead and add a decimal to it and still make sense to us. Okay, and so just because we enter the data as a whole number, such as 18, 21, 25, doesn't make it discrete. Okay? Because if we can still add a decimal place to it, and it had to be measured somehow, okay? Well, that's continuous. Okay? So, just to make sure that you distinguish between the two. Okay? All right. So there's our variables. Thank you for your time today.